this assessment reminds us that these palladium catalyzed coupling reactions proceed with retention of configuration. And yet, we're going from the E alkene to the Z alkene. So how was configuration retained? Well, let's distinguish between what's happening in the reaction and what we're indicating by E and Z. Recall that E and Z is our system of nomenclature used to give the absolute configuration around the alkene. It doesn't know what we've added or what priority it was. So in the case of calling this E, it's because the higher priority bromine on the alkene is on the opposite side of the higher priority carbon. Well, when we come over here, now the higher priority group is the ester. And so this ester group is on the same side as the higher priority carbon. And so we call that Z. Nomenclature isn't reflecting what's happening in terms of the chemistry that truly represents what we mean by retention of configuration. What we mean by that is here we have the carbon-bromine bond that we're breaking on the sort of bottom half of the alkene. We break that bond on the bottom half of the alkene, and we form the new carbon-carbon bond on the bottom half of the alkene. The fact that the reaction happens on the same side is why configuration is retained, despite the fact that our nomenclature switches it from E to Z. So don't let the nomenclature and our system for naming molecules disrupt our understanding of the fact that the bond forms and breaks on the same side in these coupling reactions.